I've got no roots, but my home was never on the ground. I've got no roots, but my home was never on the ground. I've got no roots. I've got no roots.
Hello, welcome back to my channel. Today my group will presenting about a story of abandoned cylinder bucket. Trust me, the title might sound like a creepy story, but it's actually not. Today we are going to learn about applications of differentiations, which is related rates. Without any further, let's start. On this introduction, I will introduce the topic before we proceed to the problem statement. On this introduction, I would like to introduce the topic before we proceed to the problem statement. So, we will talk about what is related rates. We heard about it, but what is the exact definitions of it? So, related rates is about a variables that involve one or more that change at the same time, but maybe at different rate. For example, if we know how two variables are related and how fast one of them changing, so we can figure out how fast the other one is changing. Related rates usually involve writing an equations relating to two variables, and it needs to be derived with respect to time. Implicit differentiations is often used in this topic. But why do we use related rates? Ladies and gentlemen, if you pursue your study in physics, engineering, or finance as well, it is important for you to learn it because it has extensive applications on it. Why do they have to learn related rates? It is because researchers will have to compare two or more quantities' behavior when they share the same common factors such as time. As example here is observing calculating the rates of change of an object kinetic energy and effective resistance.
I don't understand, bitch. Don't understand. I don't understand, bitch.
It sounds like it's hard to understand, right? So, here are some simple examples for you. Look at this air balloon. What do you guys think about this hot air balloon? What can we find here? So, for this problem, the height and the speed is increasing as the time increases. We can determine if the height or speed change through implicit differentiations. So, that's all from me. Let's proceed to the next presenter, which is Sarah, for our problem statement in this group.
Let's proceed with the story. On a rainy day, Aurelie felt bored because she could not go out to do her daily routine, which is jogging in the evening. She stared outside her house, hoping that the rain would stop. Accidentally, she saw a yellow cylindrical bucket outside her house was carrying water from the leaking roof of her house. The water slowly filled the bucket. Then Aurelie was wondering how fast the water level in the bucket was increasing. Therefore, she got the idea to get rid of her boredom by calculating how fast the water level in the bucket is increasing. She assumes that the rate of the bucket fill is 17 cubic centimeter per minute, with the radius of the bucket is 20 centimeter and the height is twice the radius. There, she started her investigation to put herself out of boredom. So, from the story, the problem statement that can be extracted is that there is a cylindrical bucket with the radius of 20 cm and the height that is twice the radius is being filled with rainwater at the rate of 17 cubic centimeter per minute. How fast is the water level in the bucket is increasing? Given that the formula of volume of cylinder is pi r square h. The next presenter represents the solution of the problem.
Hi, I'm Mazahira. In this part, I will be presenting problem solution. This is the problem statement that I have. The first thing to solve this problem is state what is given in the problem statement. Let's see what is information can we get from this problem statement. As you can see, I highlighted some part of the problem statement, which is the bucket is filled with rainwater at a rate of 7 cm cube per minute. And I interpret that as dVdt since it stated the rate of the bucket is filled with rainwater. Next, let's see what else do I have. In the problem statement also has given us the radius, which is 20 cm. We can interpret radius as small capital R. there are still information in this problem statement. It is stated the height is twice as the radius, and we can write height in small capital letter hash. So these are the information that we can get in the problem statement, which are the radius, and also the height. Second, after I get the information, we need to find what is the problem statement wants. So, according to this problem statement, the problem is how fast is the water level in the bucket increasing, which we can write it as dH dt. After we know what is the problem statement wants to solve, we need to state the equation that can relate to solve the problem. As you see that I highlighted the hint, which is volume formula for cylinder, or in this problem statement is the bucket. And here I rewrite the formula for us can see it clearly. And since we already know that the radius in this problem statement is fixed, therefore we need to insert the value in the formula. This is our new formula V equal to 400 pi hash. Next, we need to derive equation with respect to time. As for V, when we derive it, it will be dV dt, 400 pi remain, and lastly for hash, it will derive as dH dt. On to the next part, finally I am going to solve the problem. So I gather back the information that is useful to solve the problem. Here I have the derivative of the equation and the rate of the bucket filled with rainwater. Then I insert value for the rate of bucket filled with rainwater in the equation that has been derived, which is 17 equal to 400 pi dH dt. Next, I divide 400 pi for both sides and we get 17 over 400 pi equal to dH dt. Then I rearrange the calculation with dH dt on the left hand side while 17 over 400 pi on the right hand side. Then I found the answer for dH dt, which is 17 over 400 pi, and don't forget the unit, which is centimeter per minute. Last but not least, after I solve and find the dH dt, I need to write the answer in a sentence, which is water level in the bucket increases at the rate of 17 cm³ per minute when R or radius equal to 20 cm. The next presenter, Sarah, will proceed for the next part.
As a conclusion, we are able to determine how fast the water level in the bucket is increasing by using the information extracted from the story, which is the rate of bucket filled is 17 cubic centimeter per minute, radius of the bucket is 20 cm, and the height is twice the radius. We have found the dH over dt, which equals to 17 over 400 pi centimeter per minute. Therefore, the water level in the bucket increases at the rate of 17 over 400 pi centimeter per minute when the radius is 20 centimeter.
These are the references that we use for this group work. I will link everything in the description box down below. Thank you so much for watching. Bye!